So we're out here on the roof of an apartment building in Brooklyn, New York, and we're looking for meteorites, pieces of rock and metal that have fallen from space and have landed here on Earth. We're obviously not going to find anything big, but tiny micrometeorites, they're actually everywhere. They look like the period at the end of a sentence. But under the right microscope, they're incredible. We enlisted the help of the amateur scientist who proved that micrometeorites could be found. And using his technique, we're going to try to find some for ourselves, somewhere here.
I'm now realizing how much work it's going to be to find one of those. Because everything, it's picking up so much, and they're all so tiny.
You don't spend your day tripping over big meteorites because they tend to burn up in the atmosphere. You see a shooting star instead. But really small ones, or small bits of big ones, do make it down to Earth. We're talking 1 or 2 or 300 micrometers. That's maybe the fifth of a millimeter across. Those are sometimes too light to burn up. Instead, they can melt into little molten blobs and drift down to the surface.
The entire process of melting, recrystallization, and deceleration is just within a fraction of a second, so it's practically instantly.
Here's our meteorite guru, Mr. John Larson. He's a jazz musician turned amateur scientist, and over the past few years, he's stunned the scientific community by finding and identifying more than 1,000 micrometeorites. The way John tells it, scientists knew that literally tons of specimens were landing on Earth all the time, but no one thought that they could be located and verified.
Everybody agreed upon that it was completely impossible to find the micrometeorites in populated areas of the world. And at the same time, everybody agreed upon that the daily influx from space is nearly 100 metric tons of cosmic dust. So I said, 100 metric tons, and it's impossible to find it. It doesn't add up.
Some estimates put that closer to 60 tons daily, but either way, it's a lot. There wasn't a lot of data out there about what micrometeorites actually looked like, so John reversed the problem. He became a painstaking expert on all the other kinds of terrestrial matter out there: sand, grit, and tiny bits of metal.
I had got that far that I had classified all the terrestrial dust particles from all over the world, actually. And by sheer elimination, then I started finding the micrometeorites.
We're on our roof because that's John's trick for finding them. He estimates that a 1 square meter patch of ground gets hit with about 1 micrometeorite per year. This roof is 3,500 square meters, which means 3,500 micrometeorites hit it year after year after year. But we'll be happy if we find just one. So, the method. John estimates that about 80% of micrometeorites are metallic, so we'll focus on those. A powerful neodymium magnet will help us separate the particles that we're looking for from other dust and gunk.
I'll just do these 2 corners, I guess.
Yeah. The magnet should find specimens that have iron or nickel in them. The best places to search are flat roofs with little to no foot traffic. High walls can also help prevent micrometeorites from being carried away by the wind.
All right.
After about 30 minutes of collecting, we took our samples back to the office for imaging. But first, there was a little bit more prep to do. The next step is cleaning what we've got. The samples are dirty, so we're going to clean them off with warm water and a little dish soap. The micrometeorites should sink, so we can pour off the dirty water, rinse, and repeat until all the dirt is gone. After letting our roof mud dry, we need to toss out the particles that are too big. This flour sieve has 300 micrometer mesh, so by the end, we're going to be left with clean metallic candidates that are no larger than 300 micrometers. Before we image with our microscope, we studied up on what they should look like. We have John's book, In Search of Stardust, plus a ton of bonus photos that he sent us. John says he wasn't prepared for the sheer variety that he found.
Not 2 micrometeorites are alike. So within the first year, I had found 500 different micrometeorites, and they were all different. From glassy spheres until elongated and with various types of metal beads scattered around. So it was a complete new mapping of a new type of rock.
There are also imposters to look out for, little bits of rounded rock and metal that originated here on Earth. John has these cataloged too. They can be natural. Lightning strikes, for instance, can kick off tiny molten rock particles, but a ton are man-made. Fireworks can spread the earth with metallic detritus, power tools can shave off flecks of metal they cut, even roofing tiles can shed bits of sand covered in iron-rich glue. With the knowledge of what to look for, we started our hunt. And it wasn't easy. For 3 days, we searched particle by particle, looking for anything that might resemble a tiny pearl amongst other jagged pieces of dust. Like this one, perfectly spherical but perhaps a little too smooth. Or this one, glass-like with what appears to be a piece of metal protruding from it. Or this one, a rough red sphere. Altogether, we gathered roughly 19 specimens, cataloged them, and separated them from the rest of the samples, one by one by one. This was no easy feat. Just transferring the particles over to their containers required the precision and accuracy of a wet toothpick.
I lost that really pretty one that I showed. The one that I showed the whole office when I was calling people over. I lost it in the transfer.
The last step is for the professionals to check our work. So we sent our samples to Norway to be imaged by John. Now, there's a reason John's images look so much better than ours. It's because he partnered with a geologist named Jan Brole Hille. John approached Jan to ask for his help in imaging the micrometeorites, and Jan took some convincing.
When I first mentioned interplanetary dust, I just smiled and was close to taking the phone down because I thought this was madness.
But he signed on and built a whole new system for imaging John's samples. A micrometeorite is so small that you can only keep a tiny cross-section in focus at a time. To get a full image, you have to photograph multiple slices, each with a slightly different focus, and then stack the photos together to create a composite. Do that with a couple hundred images, and you get something that looks like this. So we just got an email from John. He spent a few days going through our samples that we sent him, and we're going to go through the results. Okay. The tape and lid on each box was removed before examination. 2 of the boxes were found empty. All right, so a couple of our samples clearly didn't make it all the way to Norway. That's a bummer. So number 1, no candidate found in the box. So number 2 is an iron oxide spherules. Number 3, most likely terrestrial. Number 4, also an iron oxide spherules. Number 5, iron oxide spherules. Number 6, iron oxide spherules. So a lot of what we found and what John says he has found were iron oxide spherules. And he says that they're caused by a lot of mechanical human activities like grinding, angle cutting, and they're distributed throughout the world through rain, wind, and just normal foot traffic. Number 8. No spherule could be seen in the box, which was opened and examined, but nothing was found. Number 13. This was a cool one too. He says, glassy spherule with a small metal bead, but this is too small to give a definite identification under a microscope. So that's not a no. So John didn't find any good candidates in the first 14 boxes, but in the 15th box, he found this, and he asked Jan to image it using his technique. The sample was slightly darker, a little bit more elongated, but at the end of the day, John says that this too was probably terrestrial.
Damn.
Yeah. So while our results are a little disappointing, it's good to know that there's someone in the world who's dedicating a lot of time to this project. John's next steps are trying to figure out where in the universe all of these micrometeorites came from. Some scientists think that the material comes from the asteroid belt between Mars and Jupiter.
Others think the micrometeorites come from much further out in the our own solar system, from beyond Neptune, out in the Kuiper belt and the Oort cloud. But we also know that some of the micrometeorites contain presolar grains, matter that comes from outside our solar system and is older than our sun.
Each new micrometeorite is its own mystery. You could spend a lifetime wondering about a single specimen. John's even found a few that are covered with a sort of glass foam, and no one knows what that's all about. But here it is. It never gets old.
I think they are very beautiful, and I think, and surprising, I found 1,340 as of today, and I still, each time I find one more, my heart really jumped one extra beat.
Hey everyone, thanks for watching. This is the first episode in a new series we're working on called Trial and Error, where we try a new experiment every month and document the process along the way. Stay tuned for more and let us know in the comments below if there are any experiments you'd like us to try. Thanks.